Okay, what we're going over is this is on page 254 in the Cordy book, the statistics book, and we're going to go over a single sample t-test and how to evaluate the information using the single sample t-test and SPSS. So what this asks us first to do is to ask us to type the information in the data view. So when we first do type the information in, it comes in as a string, and then we have to go in and label it. So what I'm going to do is I've already done that, but I'm going to come over to variable view and I'm going to show myself how to do it just in case. So you change your name to num underscore chips like it shows in the book. And then on your type, if you click on the arrow down in the window, then you have variable type. And right now it is numeric, but before it was string. So you're going to type on numeric, and the example it gives us has 2 decimals. So we're going to click on 2 decimals. And remember, 2 decimals is standard formatting for our APA. So we have that. That's good. So I'm going to go back to my data view, and I want to come up with information for this single sample t-test. So first thing I'm going to do is I'm going to go to Analyze, and from Analyze, I'm going to go to Compare Means and Proportion, and then do a one sample t-test. This one sample t-test, I'm going to move it over so I can go over it with you again. So when I first open this window, I have num chips, so I need to move those over because it's the number of chips I have in a cookie. So that's what that means. And my test value, my data tells me that I need to enter a test value of 27.78, and that's my test value, and then I hit OK. Once I do that, I come up with my output view, and it comes up with 3 different charts. The first chart tells us what our null value is, which is 10, our mean, which is 26.1, standard deviation, which is 2.68535, and then standard error mean. Now, what we will look at is our mean here is 26.1. Our test value is 27.78. Remember, we set that when we set up the chart itself. So if I need to go and I look at my information here, I have 26.78 and 27.78. This is smaller than this test value. So this is my mean difference. So I'm going to subtract this 27.78 from the 26.1 minus 27.78. I get the negative 1.68. So that is my mean difference. And I can tell then that since I have a negative, it's going to tell me everything I need to know. So our t value is equal to negative 1.978, and you have that there. Our degrees of freedom is 9. And then our null hypothesis, and we always consider that a null hypothesis is 0.05. So our null hypothesis is 0.05. We need to see, is this more or less than 0.05? Well, this is greater than 0.05, our two-sided p-value. So with that, we're able to see that this is, we're going to look over here at our confidence interval, and we see if 0 is included anywhere in here. Well, with a negative value going to a positive value, we see that 0 is included. And with that, we know if 0 is included in this data right here, we know that our two-sided, this information right here, the 0.79, is going to be greater than our null value, which tells us that the test is not significant. So it's not going to cause any significant issues with that test. And down here we have Cohen's d. We don't have enough to calculate the information, so we can do it by hand, but that's not something that we're doing right now. But this just tells us that the 95% confidence interval for the difference between the population means ranging from the lower bound of negative 3.6 to an upper bound of 0.24. So this test is not significant. And just a reminder, if this value here, if it includes 0 at all, this value here is going to be greater than our null value, which is 0.05. So this, anytime that happens, that means it's not significant. So that's how you interpret the data on a simple t-test.